Let's proceed to center of gravity. When we talk about center of gravity, what does it mean? Center of gravity, or what is also called the center of mass, it is the point where the weight of an object acts. So center of gravity or center of mass is the point where the weight of an object acts. That's center of gravity. So center of gravity is the point where the weight of an object acts. Now, for regularly shaped object, the center of gravity is at the middle. For example, so for regular shaped object, the center of gravity is at the middle. But for irregular shaped object, the center of gravity is closer to the point where more of its masses are concentrated. What do I mean by this? If you have an object like this, you can tell that this object has a regular shape. Center of gravity is at the middle, so the weight acts vertically downwards at the middle. If you have an object like this is not a regularly shaped object. Center of gravity will be closer to the point where more of its masses are concentrated. Is that okay? Now, a very important thing I want to say, if I put a pivot here, let's say the pivot is at the distance of A from the center of gravity of this body, this weight of this object has a moment about the pivot. The moment of the weight of this object about the pivot is the product of the weight and the perpendicular distance from the pivot. Note that. If I then decide to move the pivot here, then the weight of this object will not produce any moment about the pivot. So if the pivot is at the center of gravity, if pivot is at the center of gravity, weight does not produce moment. Weight of object will not produce moment. Note that. It will be the other forces acting on the object or the other weight acting on the object that will produce a moment. Very important. But if the pivot is not at the center of gravity, then the weight of the object will also be contributing to the moment. But if pivot is not at center of gravity, then the weight of the object also adds to the moment, to the total moment on the object. Is that clear? That now takes us to the principle of moment. That now takes us to the principle of moments. Consider that I have a regularly shaped object that is pivoted at the center of gravity. So we don't need to worry about the moment of the weight of the object itself. And I have a force or a weight F1 acting at the distance x from the pivot, and also a weight F2 acting at distance y from the pivot. The moment produced by F1 about this pivot is F1 times x, while the moment produced by F2 about this pivot is F2 times y. The question I want to ask you, what is the direction of this moment about this pivot? The force causes this bar to turn in this direction, which is anti-clockwise. Why this force F2 causes this body to turn in this direction about the pivot, which is clockwise. Now, if this bar turns anti-clockwise under the influence of all these forces, under this arrangement, if the overall direction of turning of the bar is anti-clockwise, which of this is correct? Which of this is correct? Number one, it shows that F1 is greater than F2. B, it shows that F1x is greater than F2y. C, it shows that F2 is greater than F1. D, shows that F2y is greater than F1x. If the bar turns anti-clockwise under the influence of these forces, what does it mean? It does not imply that force F1 is greater than force F2, because what we're talking about is turning effect. So A is wrong. But it means that the moment of F1, which is F1x, is greater than moment of F2, which is F2y. That's what it means. So the correct option is B. It also does not mean that F2 is greater than F1, and it does not mean that the moment of F2 is greater than the moment of F1. Now, the next thing I now want to ask you is this. If the bar does not turn under this arrangement, what does it mean? Of course, some people will say that means that if the bar does not turn, that means that anti-clockwise moment has balanced the clockwise moment, so that F1x is equal to F2y, which is correct. But the primary meaning, the primary implication is this. If the bar does not turn, it means that the resultant moment on the bar is 0. If the bar does not turn, there's no moment. Resultant moment on the bar is 0. So the bar is in what? Equilibrium. So we can say that for a body in equilibrium, resultant moment is equal to 0, which means that algebraic sum of the clockwise moment and the anti-clockwise moment taken about the same point is equal to 0. That means that the total clockwise moment is equal to the total anti-clockwise moment. So I can now say that F1x there is equal to F2y. So what this basically means is that the principle of moment states that the principle of moments states that for a body in equilibrium, algebraic sum of the total clockwise moments and the total anti-clockwise moments taken about the same point is 0, i.e. total clockwise moment is equal to total anti-clockwise moment about the same pivot. Or about the same point. So that basically means that the total, if a body is in equilibrium, total clockwise moment is equal to the total anti-clockwise moment about the same pivot. And that is what we are saying here, that the algebraic sum of the clockwise moments and the total, I don't need to put total here, so excuse me for that. Let me, so that I don't repeat it. So for a body in equilibrium, algebraic sum of the clockwise moments and the anti-clockwise moments taking about the same point is 0. Algebraic sum of the clockwise moments and the anti-clockwise moment taking about the same point is equal to 0. The anti-clockwise moment is taken to be the positive moment in the positive direction, while the clockwise moment is the negative moment. So when I add the negative to the positive, it has to be equal to 0 for the body to be in equilibrium. And what that basically means is that the total clockwise moment is now balanced by the total anti-clockwise moment, which is the principle of moment. So the principle of moment states that for a body in equilibrium, algebraic sum of the clockwise moment and the anti-clockwise moment taken about the same point is 0. And what that means is that the total clockwise moment is equal to the total anti-clockwise moment about the same point. So the next thing we now have to do is to look at an illustration of this.